Find the amplitude, the period, and the phase shift, and sketch the graph of the equation y equals 5 cosine of 2x minus pi plus 3. Well, if we have the equation a cosine of bx plus c, then the amplitude can be found by computing or by simply observing the value of the absolute value of a. That's 5 in this case, and so the function that we're graphing will go up and down to values of plus and minus 5 as their maxes and mins. The period can be computed using the values of a, b, and c as well. We can do 2 pi divided by the absolute value of b to get the period. That's 2 pi divided by 2 in this case, or simply pi. So this curve will have a period of pi. And the phase shift can be computed by doing the opposite of c divided by b. We have to be careful here. The c value is a minus pi, and so the opposite of minus pi is going to be positive pi. And when we divide by b, which is 2, we see that the phase shift will be pi over 2 units. One other piece of the puzzle, this plus c here takes the entire function and shifts it up 3 units. We could view the portion of the curve here as a function f of x, and for that f of x we have this amplitude, this period, and this phase shift. What we're doing then is taking that f of x and adding 3 to it, which shifts it up 3 units. Okay, so we'll put all those pieces together as we sketch the graph. One more thing that is often helpful is to start with the argument 2x minus pi that was inside the cosine function, and put that between 0 and 2 pi to find out what one cycle of the cosine curve will look like, or which span on the x-axis will produce one cycle of the cosine curve. We do that by solving for x. So if we add pi everywhere, we have 2x, and add pi to 2 pi, you get 3 pi. Divide by 2, we have pi over 2 less than or equal to x less than or equal to 3 pi over 2. So that range of x values will produce one cycle of the cosine curve from peak to peak, where remember that the cosine curve starts at, the unchanged cosine curve starts at a peak of 1 and ends at a peak of 1 as well, with a minimum of negative 1 happening halfway in between. Again, for an untransformed cosine curve, that all happens on the interval from 0 to 2 pi. So we're going to sketch our curve that we were requested to sketch. We're going to go up and down to plus and minus, well, plus and minus 5 as a starting point. I'll correct for the fact that I have to shift this curve up 3 units as my last step. Now, so I'm really going to ignore the plus 3 just for the initial graph, and then I'll shift it up 3 units to correct all of that at the end. So the amplitude is 5, and we've got that sketched. The period is going to be pi, and that's going to happen on the one cycle is going to happen on the interval from pi over 2 up to 3 pi over 2. Of course, 2 pi over 2 is pi, and then 3 pi over 2 gets us to here, over 2. Maximum of cosine will occur at the left-hand point and at the right-hand point of that interval. The minimum will occur halfway in between, and we'll have zeros halfway in again in between each of those values. So between pi and pi over 2, we have, what, 3 pi over 2? I'm sorry, 3 pi over 4. We can add those. Pi over 2 plus 2 pi over 2 is 3 pi over 2, and then divide by 2 to get the halfway point, 3 pi over 4. And this will be, what, 5 pi over 4? By a similar argument, 2 pi over 2 plus 3 pi over 2 is 5 pi over 2. Divide that by 2, you get 5 pi over 4 as the halfway point. And so the curve that we're supposed to sketch looks like this, except that it's 3 units higher. So I'm going to switch colors in my pen to sketch the rest of this. Our axis is going to have to go a bit higher. Everything's been shifted up by a factor of 3 units. And so this curve that had a peak of 5 is now going to have a peak of 8 when I shift it up 3 units. The minimum of 5 is now going to go up to a minimum of negative 2. Here's another peak of 8. The zeros will now appear 3 units higher. So this, what used to be a 0, is now going to go up to 3. And my curve looks a bit like that. So there's the refined curve that includes the vertical shift.